Alright, here I go again with the part 23. Alright, this is from Amlet Core class, which is Amlet Core Standard. I always been a standard English, so next year I'm having a college and career math so I can get a good credit. It was made on December the 13th of 2020, and Mr. Spencer said something about, um, Mr. Spencer said something about this page, but there's some version history that okay, so Mr. Spencer said he also said on it, but it got removed for some reason. My first semester courses just gets removed for some reason. Yeah, you passed it, duh, obviously. But alright, there's Simon, the slide that we have to do. This is a Hero's Journey in Zoe by Quinn. It is, let's start with this. Enon stage. Mai's confrontation tells me more information to give the tour about the history in the end. Enon may ask guards to tell them to be kind and let them surround the attackers who are inventing this session. The magic may event for the mythology of the hero's journey to choose parents to be on side. This is Enon. Commander Kaya. Kaya is a fierce of a king who truly loves the gods and emperor on the trusting opinions and services of what they need to discuss the conversations. Kaya may be heard in mythology, truthful, open-wise, as a dream coming true as a commanding middle part. Kaya can be disgusted by and terrific and terrified by magic that is actually terrific of what is going to happen with her and reviving the diviners by maggots. If you don't know what maggots is, then I'll explain to you after we get to the more Google Doc assignments. I'm still in this Google Slides. That's what I'm in. So yeah, this is that. Thane stage. Thane is known for his brotherly love towards Zali as well as fixing Zali's mistakes very often. Thane can be powerful too and rotate the mythologist powers for the stage romantic relationships above the world to discover more information to the book. Thane intensifies his feud on a team with Zali. Zane can help Zali not to be frightened about what is going to happen on the attackers. So this is Zane. King Saren. That's that. King Saren is known to be a real king at all times. For the middle of the end of the book that represents the diviners about them. King Saren is a ruthless king with murder around the bases around diviners are arguing everything and talks about things through and adjust any contact on the trouble. King Saren could be nice, but taking more identical memories of journeys, who is describing the perfect kingdom. Everything could be in the future, so everything could be like something could happen in the future, like many news can report. Excuse me. Sorry, excuse me. My apologies. All right, so it can be more about identical memories. It can be anything about that. It can be what is going on with the future, or it can be going on with the past. Can still talk about it, even though they can still think about the past. Can be remembered at all times. Obviously, you obviously know this for like seventh grade or so, or sixth grade. I can't tell. Sorry. Scrolls. Scroll is a part of the book and it can release on the back on the memory in which finders can use from that idea. Scroll can be a luck for the artifacts and it could be artificial due to destroying matter. Scrolls can also make powers that restore the mythology fun that touch the magic spell is at least worse for that one. So this is a scroll. New to the list. Novelist is Tony Adeyemi, and she does quite well with the beginning about what happened to the characters that took the info for glimpse and the thoughts of how they recognize. Novelist is a part of the mythology claims that is happening now. It can be used for the generation of in the book and the story of full info. So this is a person writing the mythologist, just like a mythologist is a novelist. Bone Bagger. Bone Bagger is a part of a soul in a book that collects to the middle of something that is specifically challenged for the demand. That is the beginning. That can be the exchange of the mythology methods that can put you back in the beginning about all detailed. Bone Baggers reminded, as always, to be demanding scrolls, which is you have to demand scrolls like all time if you have something to detail that it can talk about, something that can relate, something that is like related to Bone Bagger or something like that. You can do whatever else you want. All right, so I'm going to review this. Read this if you don't mind. All right, so org structure, detailed process description, portrait of desired behavior, technical specifications, and committed project results budgets, policy and regulatory changes, physical infrastructure required. So it's all required to talk about those things. Even if you have questions, then you can talk about that more detailed or something like that. Whatever else you want. Benta's stage. Benta is a friend who is a handmaiden to Princess Amari. Benta can be used for the book at the beginning, in the middle to remind the developing the advice for people. Benta may find interesting to go through the legendary tales of a King Saren's palace, and is Amari's only friend. Benta can be focused to Simone to the throne room too, which can be explained to the other part of the book. All right, next assignment. Okay, so previously was made by ICP, which is Integrated Chemistry and Physics. So, and this was made the by the end of first semester, and I got a B. I got a B something on my ICP. I was really good at it. I'm a really good scientist. Can't wait to be the scientist in the future when I do labs more like this. It was sometimes edited by the 2019, so yeah. All right, so possible terminology. ABCs by Quentin Simpson. Absolute zero. The first one is absolute zero. The lowest temperature is that is theoretically possible at the which of the motion of particles that constitutes heat would heat. It is zero on the Kelvin scale, equivalent to negative 273.15 degrees C, or negative 459.67 degree F.E minimal. So you can explain that could be described about um, the other parts as well. So let me remove it around here. Let me move this around. All right, so this is the human body temperature, which is about like 310.15 to 37. Room temperature is from 258.15 to 25. Freezing point of water, 273.15 to 0. Absolute zero is obviously 0 into negative 273.15. All right, so 37 to 96.6, 25 to 77, 0 to 32, negative 273.15, and negative 459.57, 310.15 to 96.6, 298.15 to 77, 273.15 to 32, 0 to negative 459.67. All right, so 100C. 0C, and negative 273C, which is a centigrade, absolute zero, Kelvin, 0K, 273K, 373K. This is a freezing point of water, and this is a boiling point of water, which is all those described that can you remember in chemistry class. You ever learned it for the chemistry class? Let me know in the comments below. Water boils, water freezes in absolute zero by degree F and degree C in kelvins, which is a 212 degree F, 100 degree F or C, 100 degree C, 373.15 K. 32 degree F, 0 degree F, 0 degree C, 273.15 K. Negative 459.67 degree F. Negative 273.15 degree C, which is at 0K. Absolute zero, the freezing point of water, is 273.15, which is to zero. And absolute zero is 0. Negative 273, which can be all those numbers that can, it means repeatedly 10 times. You have to add 10 times to add the same number amount, which can be explained on that video. So so yeah, 10 more and it adds all this right there. Just add 10 more and then you can actually see what it's actually been heading to. All right, so you put this down right here and I'm gonna. All right, next slide. All right, so boiling point. Yeah, Mr. Murphy was actually helping me on this to get me remembered for the test. To do it for a free slide that I need to fix, but sometimes I got it through enough. So, all right, so this is a boiling point. The second one is boiling point. The temperature at which liquid boils and turns to vapor. I could just added more sentences in general, but now I'm gonna be yeah. All right, so this is a water vapor, and the water that it's coming from. Those are some red pieces or red things. You can actually tell that is some atoms that are in the water. This is the jiggling atoms in boiling water. Okay, so this is the molecular level and macroscopic level. So this is the A, which is a heated water, which is where the heat comes from, and the room temperature water is B, and chilled water is C. With if the water is too hot, then it is actually heated, and it can actually burn the water, or if you make it burn. The room temperature water is actually the same temperature at home. It actually feels normal, but it feels warm or cool. Chilled water is actually cold, like freezing, like the snow. It can actually, when you're drinking a drink, if you're drinking a soda or if you're drinking like a iced tea, any etc., you can feel the coldness. Or even ice cream too. Ice cream can be way colder. Way colder. Or evaporation is actually the vapor pressure. Atmospheric pressure bubbles cannot form. If your evaporation is bubbles cannot even form. Like boiling is actually vapor pressure, atmospheric pressure, bubbles can form and rise. Yeah, bubbles can only form in actually boiling point. So this is what boiling point is all about. So just to keep in mind. All right, cation. The third one is cation. A positively charged ion, I point E point, one that would be attract to the cathode in electrolysis. So you can actually tell the difference. All right, so this is what it looks like in general. You can actually see the generation of cation, the generation of anion. You can actually see what is actually doing to those kind of electrons. You can see what the electrons are doing. Comment down below, what are the electrons doing? Right, so this is what it looks like when the electron rises. This is what it looks like. This is anion clone Cl. This is what it looks like in general. This is what it looks like when it rises a little bit, and it rises just like that. And this is rises that ball is like refusing to get down, which is a Cl, which is the regular Cl. So yeah, all right. There's I'm gonna pretend it's the sun. There's the anion versus cation. How can you tell the difference between the anion versus cation? Tell me the difference between the anion versus cation. Comment down below. Ions, cation plus negative anion. So this is the ions. I'll give you a few minutes to know what is the difference between anions versus cations. All right, density. The fourth one is density, a measure of the amount of information on a storage medium, tape or disk. For magnetic tape, it is the amount of information recorded per unit length of tape. Bits per inch, a millimeter. For disk, a fixed number of bits per sector, sectors per track, and tracks per disk. To be honest with you guys, I'm actually a really good scientist, so you're gonna find it really, really good. All right, so G equals 1,000. All right, so parentheses, in parentheses by 1. All right, so 1 minus in parentheses by up top is T plus 288.9414. On the bottom it says 50,000 and 8,929. In parentheses by T plus 68.12,000 and 9,630, which is equals and the last answer is in parentheses by T.3.9,863 in 3.9,863 squared. So this is the answer. What is density? Density is the amount of matter in a specified area. The basic unit is grams free squared. This means that the density of a material will be the same no matter how much of a material there is. Density is also different for different materials. Like this is actually showing what is actually made by right here. Excuse me again. All right, so this is the first one is He, which is 4 which is 4, which is a 4.00 G mole. Right, so CH4 16.0 G mole. CO2 44.0 G mole. Air 28.8 G mole. 20% O2, 80% N2. 2 in the bottom. Right, so the intensive or extensive properties depend on the amount of matter that is present. Intensive properties do not depend on the amount of matter that is present. extensive mass, volume, length, and or shape. Color, taste, melting point, boiling point, density, luster, and hardness. Most of them are actually intensive, but the extensive is actually pretty much low because it only has 4 of them. But intensive is the most thing that can be is only per, it's the only thing that's actually the amount that could be that could be written about there. So that's all about density. If you have questions about those slides, let me know. All right, so the electron orbital shells. I put Mr. Murphy as an editor, even though I accidentally um, made it to C become the editor. I didn't mean to, but okay. The electron orbital shells. The fifth one is electron orbital shells. An electron is the outside part of an atom around the atomic nucleus. It is a group of atomic orbitals with the same value of the principal quantum number n. These suborbitals have 2 or more orbitals with the same angular momentum quantum number 1. Electron shells made up the electron configuration of an atom. So let me screen share there. Excuse me again. So this is the described here. All right, so n equals 4 in parentheses by 4th shell. Freed subshells by S, P, D, and F. This one here is actually n equals 4 and n equals 3 and n equals 3 third shell in parentheses, free subshells S, P, and D. This is the nucleus, which is n equals 2 and n equals 1. N equals 1 in the first shell, in parentheses, first subshell S, which is located, it has been written in those kind of cases. N equals 2, second shell in parentheses, 2 subshells with S and P. They only connect in short waves. Excuse sorry. Orbital flown per center, reference plane, insulate in insulation, epicenter, argument or pericenter, argument of pericenter, which is the argument that I made a video for a long time ago, which is arguing my cousin. It automatically connects to the feeling of arguments. Ascending mode, longitude of ascending node, origin of longitude, which can be explained, which has been written by multiple times. All right, so this is so many degree by first energy level and a second energy level and third energy level and IV energy level, but is nucleus, the plus. You can actually see it right above there, which is which those levels include the IV contains by 32 and the 3 contains by 18. The 2 includes 8 and 1 concludes 2. So that could be explained by that. And the first one actually concludes by K, and a 2 concludes by L, and 3 becomes by M, and 4 becomes by N. And the nucleus is just the nucleus is just about like the plus that I can see above right there, where I'm pointing. The dumbbell-shaped pyramidal portals of second shell. Oriental oven shell. I cannot read the ZN shell. Zertoitol of what it has been written here. Yeah, it has been written by a multiple by many things. Can include by shaped apirtol, or it could be more things about it. So that's all for electron orbital shells. That's all. There's no things that are F or G, but there is one for H. So let me represent here. Is it moved? Okay. The sixth one is homogeneous mixture. Homogeneous mixture. A homogeneous mixture is a solid, liquid, or gaseous mixture that has the same proportions of its components through any given sample. Conversely, a heterogeneous mixture has components with proportions that vary throughout the sample. All right, so the het- heterogeneous mixtures is about a heterogeneous mixture is which substances and eat evenly mixed. Often you can see the different substances in parts of a hidden heterogeneous mixture will unadded eyes. Sometimes you can see them only with a monoscope. Or I can't read what it says, I'm sorry. Alright. Torch A for B, path of light becomes visible. Figure 2.3. Solution of copper sulfate does not show Tyndall effect B. Mixture of water milk shows Tyndall effect. Homogeneous versus heterogeneous mixtures. The homogeneous mixture is a mixture that has a uniform appearance and composition throughout. A heterogeneous mixture is a mixture in which you can identify the component parts just by looking at it. The homogeneous mixtures are often indistinguishable for the pure substances on a macroscopic level. You have to consider the unknown sample of the molecular level to determine if it is a mixture or pure substance. Which can be written here. The homogeneous or heterogeneous is actually this. You cannot read what it says, but that's okay. I'll move on without that. Let me move this out of the way. Solutions. A solution is a mixture formed when one or more solutes dissolve in a solvent. Water solvent in a sugar solute. Sugar solution is obviously solution, which is kind of like you're putting like baking soda. It kind of reminds me of baking soda when you're doing something like when you're pouring with water and put baking soda. I'm not sure what it does, but just let me know what does water. What happens if you put baking soda into a water? Let me know in the comments. All right, that's all you know about homogeneous mixture. If you still have questions, just let me know. I'll be happy to help. All right, so ion. Sorry about that. Ion, the seventh one is ion, an atom or molecule, the net electric charge due to the loss or gain of one or more electrons. This is shown right here, and this is shown like you can find it at www.shutterstock.com, which is 103657761.195. Okay, so explain here. The carbon atom is right here, which is a 6 protons, 6 neutrons, and 6 electrons. We learned it. I actually heard of this for like since like 7th grade or 8th grade, and I actually 7th grade. Yeah, because Mrs. I cannot remember her last name was, but I think I know. Yeah, I'll explain to you later. A magne a magnesium atom is actually 12, so it's 12 protons and 12 neutrons and 12 electrons. A calcium atom is 20 protons, 20 neutrons, and 20 electrons. Does it matter? Does it add any number? No, it just stays 20, and it stays 12, and it stays 6. So yeah. All right. So this is let's look at this here. So this is two out of three negative, which is O and an N plus and an O, which is -2/3, and this is the O, which is 2 out of negative 3 minus. So this is VF, and this is 1, and this is 2. They are 5 twos. They are 5 P's, and they are 4 S's. So that this is where it comes from. This is where it locates. How many gains? How can it add more electrons? It just stays. It just looks. Yeah, it looks like that. Yeah, it does. This is what ions come from too. Or even if, like I said, if you have any questions, just let me know. There's no one that starts with J, but there is one that says like kinetic energy. The eighth one is kinetic energy, energy that a body possesses by virtue of being in motion. K equals 1/2 IW2, 2 squared. And this is a girl swinging, which is actually the kinetic energy that is actually moving, which has actually been written by the girl swinging, and it actually starts the movement. I actually learned this for like 2nd grade. I actually know what movement actually is because I know what moving can be all about. Like movement that I'm talking right now, it automatically moves like right away. This is actually science. This is for education, definitely. All right, equation for GPE. This is a person holding something up here, and there is a building that has been he was like staying still, and I don't know what he's holding. Just let me know in comments. All right, this is the woman jogging, and this is a KEH. This is up here, which is accelerometer data, activity classifier, and accelerometer. This is a radio. The kinetic energy of an object arises for the network clone on it. This can be seen, for example, of using a constant net force to accelerate a mass from rest to ephemeral velocity. So Ke equals kinetic energy equals 1/2 mv squared. Kinetic energy. F represents the net force. F m v 0 equals 0. D equals Vt equals Vt over 2, which is T. V equals average velocity. V equals VO plus V, which is V question mark. I can barely see. Divided by 2 equals V1 divided by 2. F net gives acceleration equals MA. Not work is equals FD equals MAD equals MAVT equals m vt divided by r vt divided by 2 something equals 1 divided by 2 mv squared equals kinetic energy. All right, so let's start with this one. A equals F divided by M equals VT divided by T. A equals triangle V divided by triangle T equals VT. VT, I cannot tell the difference. Negative 0 divided by 1 divided by T equals V1 divided by T. So this is the distance D. This is I cannot read what is in a time, which is the T. All right, like I said, if you have any questions, just let me know. All right, I'm gonna save this part for part 24, so I'm gonna leave it be.